Hey guys, welcome back to Jacklet Educational Channel. I hope you all are doing well. So this video we are going to discuss some of the frequently asked questions in the environmental science entrances, and be ready with the pen and paper to note down all these. And if you haven't joined our Telegram group, make sure you have joined, that is the Learn for the Environment, to extend your preparation. So let's start today's video. So we'll start with this question. This is also one of the frequently asked numerical in the environmental science entrance examination. So let's read the question. It is a very chocolate question. The question is, if the half-life period of a radioactive substance is 0.693 years, the question asks what will be its decay constant, and the options are 0.2 per year, 0.1 per year, 0.5 per year, or 1 per year. So in order to answer this kind of questions, you should know the concept behind that. So every radioactive substance is undergoing decay everywhere. So every time it is going under decay, so its value is decreasing, that is its mass is decaying according to its property, that is the property of radioactive substance. So if you know the half-life period of any radioactive substance, so here it is 0.693, we will be able to calculate the decay constant. So here decay constant is denoted as lambda, and its unit is second inverse. So it is actually the inverse of time. So it can be second inverse, it can be year inverse, or hour inverse. So SI unit will be second inverse only. So here to find the lambda value, that is decay constant, the formula is 0.693 divided by T half. So here T half means the half-life time of that given radioactive substance. So what we will do is, here we'll simply put the values. We have to find the value of this lambda. So lambda is equal to 0.693, and coincidentally the question has given the same value for the half-life period of that substance. So it will be same 0.693, but in different question the value will differ. So here these two will cancel out, so the value will be 1. So 1 how much? 1 year inverse, because the question it has asked about years. So here the option D will be correct, that is 1 year inverse will be the decay constant of this radioactive substance, which is having the half-life period of 0.693 years. So lambda will be equal to 1 year inverse. So in this way you can solve this question very easy. I hope you are noting down this formula. Let's move to the next frequently asked question. So the next frequently asked question which we are going to deal today is the soil profile. Yes, soil profile or soil horizon, very important. Some of you will be knowing also, but here I will tell you some points which are very important to note down. So what are horizon? Horizon means the division. So in horizontal division, these are divided, the soil profile. So these are O horizon, A horizon, B horizon, C horizon, and below some time the C horizon you will find the R horizon also. So that we'll discuss separately. Here we'll know what are the characteristics of these horizons. So O horizon is the topmost horizon. You should note it here. It is the topmost part of the soil, and here it is called as the humus layer of that soil. So humus is found in this layer, that is O horizon. Next is A horizon. A horizon is the second most in the soil profile, but it is called as the top soil. So don't get confused between O and A. So A will be always considered as the top soil, not the O horizon. So A horizon is rich in organic matter, typically dark in color, and it is also called the zone of leaching. So here we will know in the next slide about why it is called as zone of leaching, and particularly which part is called as the leaching zone. Next is coming to the B horizon, which is the third horizon as per this soil profile. So it is called as the subsoil region. So this is very important. It has been asked, subsoil region, B horizon. It is also called the zone of accumulation. That means all the nutrients which are coming from above, they are accumulated here in more quantity. That's why it is called as zone of accumulation. Next part in the B horizon is that it may contain soluble minerals such as calcite in arid climates, which are called as caliche. So you should note down the term is CALICHE, caliche. That means it is having the calcite, the B horizon, in the arid climates. Coming to the C horizon, which is called having the weathered bedrock. So it is not the bedrock region. Bedrock region is the region below the C horizon, that is the R horizon you can say. So here C horizon having the weathered bedrock. So parts of broken bedrock or rotten rock which are called as found in the sea horizon. So here it is also mentioned bedrock region lies below this soil profile. That means below this sea profile. So here I would like to include one more profile which is also important. So let's move to the next slide. The next zone which I was about to tell is that E horizon. Yes, this E horizon comes in between B and A horizon. That means in between topsoil and subsoil. It is called as elevated horizon. From E, the name is given elevated horizon. So what is the characteristic of this horizon? So this horizon is having leached of clay, minerals and organic matter, leaving a concentration of sand and silt particles of quartz or other resistant materials. So here you will know that leached particles are present mostly in this horizon, that is E horizon. So here what is leaching? So leaching you might be knowing, but I will tell you, in geology, leaching is the loss of soluble substances and colloids from the top layer of the soil. So from the top layer, when these are coming by the help of precipitation. Yes, when the rain falls, it is percolating and it is carrying away the minerals and all the organic matter, and it is depositing in this part mostly, that is E horizon, that is the elevated zone. And you should also know this zone is missing in some soils. So in every soil you will not be able to find this E horizon, but it is often found in older soils and forest soil. So in the forest kind of soil you will find this E horizon. It is important to note down. And in older soil, so it has been accomplished and it has been developed through many years, then those soils will be having this zone. Let's move to the next very frequent last question. So the next frequent last question which we are going to deal today is the mark recapture method and the numerical coming from that. So here let's read the kind of question which is coming in this type of question. So the question here asked is, Rosalind wants to find out the number of ducks in a park. So Rosalind ma'am wants to find how many ducks are present in a park. So what she does is, one day she catches 50 ducks. So first she catches the 50 ducks. She puts a tag on each one, then releases them. So 50 ducks are now having all the 50 tags on them and they are released by the Rosalind. So what happens? Rosalind comes the next day and catches 20 ducks. So from those 20 ducks, 8 are having a tag on them. That means those 8 were present in the previous day when Rosalind was putting tags on them. So ये वो ducks हैं जो कि first day में Rosalind जब tag कर रही थी उनमें tag लगा हुआ था. But other than that, the 12 ducks are not having the tags. That means they are the newly catched ducks. So here we will discuss one by one. So the question is asking, estimate the total number of ducks in the park, and you should write down any assumption you made. So let us ignore this question. You will just find the total number of ducks in the park. So to solve this, I will tell you the concept behind this mark recapture method. So it is very simple. First, what you have to do, let us assume you have to find here the ducks population. So first day you will go and collect the number of ducks and then you will put the tags on them. So what will denote them as? They will be denoted as capital M. Yes, initially the number of catches along with the tagging which we do will denote them as capital M. Then what happens is, next day when you will come and catch the ducks, for example here, then the number of ducks which will be having the tags on them will be denoted as small m. Yes, they will be denoted as small m. And now coming to the next part, that is the small n. Small n will be the total number of ducks captured. So here, for example, here 20 ducks were captured the next day. So here small n will be 20 and small m will be 8 because 8 are having the tags. And now most importantly is the capital N. So what is this capital N? Capital N is the total population of the ducks, which you are going to find out in this question. So I will tell you the formula once again. So the formula is capital M by capital N is equal to small m by small n. So this is the formula, the Brahmastra, and to find out the capital N every time the question will be asked. So here the formula will be capital M multiplied by small n divided by small m. And we know n is the total population, m is the number of members catched in the first catch and they are tagged, and small n is the number of individuals captured in the second catch, and small m is the number of individual catched in the second time and which are having the tag. So I hope you are able to understand this. Very simple. If you are not able to understand, you can ask me in the comment section. So now let's solve this question. So here I have already put down the values. I will recall you. So here the value is 50. 50 is what? 50 is capital M. That means in the first attempt, how many ducks were catched? 50 ducks were catched. And X is what? 50 by X means it is capital N, which is we have to find the number of total population of ducks. And here 8 is what? 8 is the small m. And here 20 is what? 20 is the small n. That is the number of ducks caught in the second chance. So here we will assume that no tags fell off. So after first day, the tags are already intact. They haven't fall. So that's why you should assume that. And what we'll do? Simply multiplication. So what is the formula to find out the n? That is the here we have taken x. That means it is 50 multiplied by 20 divided by 8. So after solving this, we will get the value as 125. So 125 will be the value of the total number of ducks, that is the capital N, as per the formula of capital M by capital N is equal to small m by small n. So this is the Brahmastra formula. You should note down the concept also, you should note it down, and very easy question. Don't leave these kind of questions. So I hope you have enjoyed this video. We have revised this concept. I know you would have known from earlier, but you have revised them. Don't forget to subscribe the channel to get all further updates. Keep smiling and believe in yourself.